Hello everybody, I'm Antonio Pirozzi. I'm going to present a quite extensive research on EvilCorp with the title Operation Chameleon, Behind the Scenes of EvilCorp, the world's most harmful cybercrime group. Just a word about me. I'm a threat intelligence team leader for the eCrime at SentinelOne, where me and my team are mainly focused on the Eastern European cybercriminal ecosystem, mainly Russian. Actually, I'm also a PhD researcher at University of Sanya on some topics like gun-generated malware or GNN for multi-classification, and previously I was in charge of the Italian Yoroi Zlab. So this is the agenda for today. I will provide a little background on the topic. What is the EvilCorp affiliation model, the characteristics of this cluster, and we are going to do a full immersion in EvilCorp malware lineage. In this research, we were able to put into a unique cluster a lot of different ransomware variants supposed to be part of this cluster. We will see also the pager in use by EvilCorp, and the pager was a kind of distinctive element in the EvilCorp ecosystem because permitted us to cluster activities, and the pager they used for their operation is a kind of marker in which we can track all their operation in a timeline. And at the end, we will provide also some conclusions about our findings. So I want to start with the key findings from this investigation. First of all, I want to thank you, SentinelOne, to give me the opportunity to investigate this topic. And I want to thank also my colleagues, Anthony Sterefos and Idan Weizman, that supported me a lot in the technical analysis. So I want to start with the key findings of this quite extensive research. We were able to put in a unique cluster based on overlaps in terms of code similarities, pagers, activities, congruencies in timeline. All the ransomware supposed to be part of EvilCorp, like from Western Logger to the latest payload B. And also, we had the opportunity to assess also the latest iteration, dubbed Macav ransomware, and we found about it a lot of similarities inside the code, which put also Macav into the same cluster. Another important finding of this research is that we found that a portion of SOC Gaulish infrastructure, SOC Gaulish is the initial access of choice of EvilCorp, was used to deliver Western Logger and AIDS ransomware, but was also used at the same portion of infrastructure, was also used to spread Bitpaymer and Doppelpaymer by deploying the Dridex lowline. So another important finding is that EvilCorp entire kill chain is managed privately with a high level of OPSEC. They aim to avoid interferences in all their operation, in all their attack chains, from the resource development to the ransomware deployment. They tend to maintain control over the whole ransomware development process. And this is a distinct element, a distinct characteristics of this cluster. Another interesting finding is an advanced adaptive capability. In fact, since the OPAC sanction in December 2019, EvilCorp has been constantly changing their scheme, experimenting also novel techniques, new techniques to stay under the radar. We observed some TTPs over time, the evolution of their TTP over time, suggesting that this cluster have advanced capability also in defense evasion. Is one of the in the eCrime ecosystem is perhaps is the only threat actor that is able to cover all the defense evasion techniques. Before we start, I want to share a consideration. This is one of the most controversial threat actor in the eCrime ecosystem for a number of reasons. First of all, for the documented ties with the Russian FSB. Second, because in 2019, the US government put under the sanction 2 of its key members and also some malware, Dridex. For those reasons, we consider EvilCorp a kind of hybrid threat actor between in a position between espionage and classical cybercrime. So in fact, the UK National Cybercrime Agency calls it the world's most harmful cybercrime group. For this reason also, it's difficult to investigate also this threat actor, because IR companies and other companies that are engaged with those incidents are reticent to share to share closing or indicators, just for this consideration, because there are a lot of sanctions on this cluster. The origin of EvilCorp can be traced back to Bokajev. Bokajev is also known as Slavik. He's one of the key people of that founded Business Club in 28. It is considered to be the developer of Zeus banking Trojan. Business Club is a kind of matrix of what after became EvilCorp, and it consisted of a kind of 10 key people tied with the Russian government, with the support of other 15 people. Maxim Yakubits is considered EvilCorp group leader. At least the last official documents which describe him as a leader date back December 2019. The group was one of the pioneers in financial cybercrime, and this is the reason why US government decided to put a NOFAC sanction on Dridex. Dridex, which is the main loader, the loader of choice that they developed, of course, and they start operating since 2014. Dridex, of course, is responsible for was responsible for a financial loss of more than $100 million. And for this reason is in the scope, is in the OFAC scope. In 2017, they started to operate ransomware with Bitpaymer, and dropper, the loader of choice, was Dridex. Dridex was also responsible, and also today is responsible for a lot of for the major part of the mass spam campaigns. US government put Dridex under the OFAC sanction in late 2019, and then we seen a change in the TTP for initial access starting from 2020. In fact, from 2020 they started to change their payload signature with a new ransomware variant dubbed Western Logger, using different also exploitation tools and methods of initial access. In fact, we seen a switch from Dridex. Dridex was in use until December 2019, more or less, and they start adopting SOC-Golish. SOC-Golish framework is it's a framework which exploits social engineering to deliver things, to deliver threats. They started to exploit website, even in watering hole attacks. They put the malicious loader of SOC-Golish in some websites, and and SOC-Golish is have a low detection rate. And apart from this, is not in the OFAC sanction. Those are the advantage of this tool, that also presents a low detection rate, and this permits them to have a great return on their investment. So this switch, the switch from Dridex to SOC-Golish, permit also to mislead attribution and distance themselves from both Dridex and Bitpaymer, which are under the scope. This is a milestone in the EvilCorp timeline, because we know the exact moment in time when they switch at those TTPs. And this is a distinct element, distinct tactics of about them. So another change in the TTPs that we've seen is that they started using in the beginning of 2020, they started using Cobalt Strike extensively for all their ransomware operation to gain an initial foothold on the system and to perform lateral movement, instead of discarding PowerShell Empire, which was at the time the tool of choice for post-exploitation. In this slide, we reported the EvilCorp affiliation model. It's built mainly combining previous intelligence on this topic. We can see the important relation, the historical relation, drawn as rectangle in dark blue. For example, there is an historical relation with Mummy Spider. In terms also on the resource sharing. In fact, for example, Emotet, some version of Emotet and EvilCorp today use the same CryptoOne packer for obfuscate to make their code more evasive. CryptoOne is a well-known crypto as a service, and it's used also today by EvilCorp. It's not present in Macav, but it's used until payload B. Another historical relation and partnership is with Wizard Spider, which is the threat actor responsible for the development and the deployment of TrickBot. And because for a certain period, TrickBot deliver extensively BitPaymer also, and for this reason, there is a kind of relationship as an affiliation. Another things that, for example, there are a lot of tiny clusters like Doppel Spider, for example, which today also distribute Grief and Doppelpaymer, but it's supposed to be a kind of fork of EvilCorp. It's not related to the same group for a number of reasons, and also because mainly because they conducted their operation in parallel with other ransomware operation of EvilCorp that I reported in the bottom side of this slide. The bottom side, we can see the recent EvilCorp ransomware operation. So, what is the EvilCorp malware lineage? The EvilCorp malware lineage is the set of all EvilCorp, of all the ransomware strain that are supposed to be part of this cluster, that are supposed to be operated by EvilCorp. There is such a dispute in the community about attribution for a number of reasons, for the OFAC sanction, because it's a sensitive matter, because for the documented ties with the Russian FSB. But we were able in the end to put into the same cluster all those ransomware strain with a high level of confidence. I put in this timeline the important milestone or about the evolution of their lineage. All start with BitPaymer. BitPaymer is considered the first ransomware operation by EvilCorp and was seen in August 2017 until the December 2020. So Wested Locker appeared in the wild around May 2020 and was operated for a few months. After Wested Locker, in December 2020, we've seen AIDS in several incidents until March 2021. In March appeared Phoenix Logger, and then in June 2021, Payload B. In a few days ago, another malware, another ransomware strain hit the headlines called Macav ransomware, and we had the possibility to assess it, to analyze it, and we were able also to put this ransomware into the same lineage. We conducted, combining previous intelligence and also our assessment on this, we found some similarities between BitPaymer and Wested Locker. For example, the reason is we have to consider that Wested Locker is completely rewrite of BitPaymer, and for this reason, if you do an extensive similarity analysis on it, you cannot expect a high level of overlaps. So but there are a lot of elements that overlaps between those ransomware streams. For example, both use alternate data streams to hide the payload. It's a kind of defense evasion technique. Both use a customized API resolving method in order also to evade EDR. They have a similar USC bypass methods, not the same, but taken from the same repository. They use the same encryption method, and the ransom note is quite similar, have the same style of command line arguments, and victim-specific elements, another element of similarities, are added using specific builder rather than at compile time. All those elements, all those similarities are mainly are not too strong, but are the proof of a kind of knowledge reuse between the two ransomware families. And another reason that permits us to put Western Locker like the successor of BitPaymer is that, okay, apart from the similarities, there is a kind of consistency in time, because all those timelines, if we can take a look at this at the timeline that I drew in this slide, all those operations are consecutive in time and never happened in parallel. And this is an important thing, because when an operation stops and a new one begins. Taking a look at the timeline on top of the slide, we can see that when some operation ends, a new one begins. There is a kind of consistency in time. This is another element that permits us to link together all those ransomware families. From BitPaymer to Western Locker, they completely rewrite their code. Why? Because BitPaymer was put under the OFAC sanction, and in order to maximize their profit, their operation, in order to avoid the failure in their operation, they try to rewrite new things. Western Locker with a new rewrite of their ransomware, with new method also for defense evasion, and they started, in fact, to operate this ransomware Western Locker in the beginning of 2020, when few months ago their ransomware BitPaymer was put under the OFAC sanction, the OFAC scope. So there are also some differences between those ransomware families. For example, they use different USC bypass methods, but both taken from the same project, the same repository. From AIDS onward, we've seen a generalization technique. What does it mean? It means that AIDS doesn't contain any more victim information inside the ransom node. This is another technique, specific technique, that I can start using in order to avoid the attribution with certain victimology. In order to broken the link with the victimology during an investigation, because if we are able, for example, to collect different Western Locker samples, and starting from the ransom note, we were able also to map, to reconstruct the victimology of Western Locker. It's simple. From AIDS onward, it's not possible yet, because they removed all the victim-related information as a kind of technique for misleading, and instead start inserting in a ransom note a toxic channel in order to establish a communication channel with victims. AIDS does not use alternate data stream, discarded alternate data stream, and this is a distinct element in AIDS that we don't see in Western or BitPaymer. AIDS store key information in each encrypted file, while Western Locker BitPaymer store key information inside a ransom note. This is another distinctive element. For the similarity analysis, our approach was to take both two samples from both families and conduct a detailed similarity analysis on specific function. Those in this table are the samples that we used for the similarity analysis. So we assessed the similarity between the Western Locker and the AIDS about few core functions of the ransomware. In this slide, we presented the detail of the similarity of the file and directory enumeration routine, which represent one of the main, the core routine of the ransomware that is executed before the real encryption. So it is possible to see in the red bullets that they used the same implementation for storing file information. And also we found the same implementation of allocating memory on the heap, relying on the heap alloc API, and then setting to zero at all the memory, empty all the memory allocated with the memset API. In AIDS, on the right side, we found the same implementation. The only difference is that they wrapped both API into a single function, as it's possible to see on the right. But this is also the changes that we found in this specific routine, in this specific implementation. They use the same API in the same way and in the same order. The flow graph of this routine is identical between the two samples. And also in the last part of the slide, on the bottom of the screenshot, also they implemented in the same way the management of critical section, because all the file operation have to be done in a safe way. So they used the same implementation for management the critical section, relying on the same API, executed in the same order. So yes, we found the same similarity also in other important functions. For example, we assessed the drive enumeration routine, for example, and also about this function, as you can see from this slide, we have a one-on-one similarities between the two families. The same API, the same structure of the code, and the same way of managing things. So another important element of that overlaps between those ransomware families is that, for example, they both use for managing the cryptography, the encryption part, they both use API from the RSA-Ref crypto library. Is an open source project. As far as I know, is not used by other ransomware families, by other prominent ransomware families, and it's a kind of unique element that permit us, is another element that can link, permit us to link those two ransomware families together. They use the same crypto libraries for the encryptions, and in the same way. In fact, you can see in this slide, on the left we have Western Locker, on the right side we have AIDS, and they use the same RSA implementation, the same implementation taken from the same crypto library. So this is important because considering that AIDS is a 64-bit write of the Western Locker and have also a different signature inside, but at least the main function, the function related to encryption, the function related to enumeration of directory and drive and file are pretty the same. So what are the main differences between those ransomware? First of all, the architecture, because AIDS is written in 64 bits, while Western Locker in 32. But another important difference is that in AIDS, we can see the rewrite for some file-related APIs in their lower level ones. For example, some API for the file management, like find first file, move file on delete file, in AIDS are written like with a correspective in native correspective, like ZW write file or ZW query directory file or ZW close. So the rewrite in the low level APIs, it's another defense evasion techniques that they use it, but in order to adopt it, they had to partially rewrite most of their code. They put a lot of effort in rewriting their code. Why? Because they have, this is a continuous attempt to stay under the radar, to change the signature and also to mislead attribution. Another important element is that in Western Locker, the assembly code is quietly unchanged, is more or less the same, while they start adopting a new technique for devansivation in the AIDS ransomware, introducing a lot of no opcodes inside the code, the assembly code. And this technique is quite effective, called static polymorphism, is quite effective in changing the signature and then lowering the detection. We assessed also the similarity between AIDS and Phoenix Locker. I reported here in this table the information related to the sample that we used for this analysis. And a weird thing is that both AIDS and Phoenix Locker use relying on the same payload. In fact, this specific Phoenix Locker sample present the same compilation timestamps of AIDS. So considering that compilation timestamps is not a reliable indicator by nature, and can be easily tampered, we assess also the threats to validity of the compilation timestamps, and we can assert with high confidence that the compilation timestamp was not altered. So Phoenix Locker used the same AIDS payload, and a simple yes, we conducted also a simple similarity analysis between key function of those ransomware. We have on the left side we have AIDS, and on the right side we have Phoenix Locker, and we can see at first glance that they present the same structure. This in the specific, this is the routine, the function responsible for the for enumerating file before the encryption. So the structure is pretty the same. Also the way and the API for the management of the critical section that we can see, and also the same API like get drive types that we can see in both functions for managing drive and file. So during the similarity analysis, we noticed that AIDS and Phoenix Locker derived from the same code base, from the same sample. And for example, in this slide, we reported a portion of the flow graph of both samples. And in red and in blue, we highlighted the junk code that they added with this technique called static polymorphism. And they added, in fact, a lot of junk code inside, code that don't do anything, and inserted with the only intention to alter the signature. They used for both samples, they used the same payload. This is a clear and a strong proof, a strong indication that they have in their hands the code base of AIDS. The guy, the actor which is responsible for the development of the Phoenix Locker is the same of AIDS, because first of all have the same code base, and second, all those operations, I mean AIDS and Phoenix Locker, are tied together. So we assessed also the similarity between Phoenix Locker and payload bin, and noticed that there are a lot of functions which overlaps with a similarity more than 19%, as it's possible to see from the right side of this slide. We have a lot of custom functions that are not related to external libraries, which overlaps perfectly. And also, as we can see from this screenshot taken by the well-known BinDiff tool, there is 15% of similarity, taking into account function and code and flow graph, and with a huge portion of function which overlaps one-on-one. So as it's possible to notice from this slide, this is in specific file enumerating function, and in both samples are practically identical. In both samples, in Phoenix and payload bin, they added, as it's possible to see highlighted in red on the left side and in blue on the right side. Those are all the instruction, all the junk code that they inserted to alter the signature. They use the same technique that we see in AIDS. So this is from the code point of view, but also from the ransomware TTP point of view, and this configuration is there are strong similarities. In fact, for example, in the center of this slide, we have the wait for commands. There is specific TTP, specific technique of self-deletion. This technique is used to delete the payload from the system, and they rely on the wait for commands in AIDS, Phoenix Logger, and payload bin, while they use the choice command in Western Logger. So it have the same semantic. The logic is the same. In one, yes, they use a choice in Western Logger, then they changed the to wait for command in the other ransomware variant, but the implementation is pretty the same. So this is also valid for the other strain like Phoenix Logger and payload bin. Is it possible to see those are the command line, the technique contained inside the ransomware, and they used both the same wait for implementation with the same delay of 10 seconds, and yes, it's pretty the same self-deletion implementation, and also the same way to delete shadow scope in the same order. So there are also other minor overlaps that we reported. For example, there is the existence of this quite unique custom section called OBX0, and this section, this portable executable section, is we found in some AIDS sample and also in the Phoenix Logger sample. So we found also that some of the ransomware share the same mutex. The mutex is the part of the mutex is based named object scriptnet, and is shared between AIDS, Phoenix Logger, and it's present also in the latest payload bin. So we have another mutex, CTF, and it is present also in some AIDS samples that we reported, and also in the payload bin variant. So in the end, we put all those findings in this diagram in order to highlight, to emphasize more the commonalities, the overlaps between in terms of code, and it is possible to see that at first glance that there are strong overlaps in terms of code that we've seen, of course, and also in terms of some artifact related to the development pipeline, like the mutex, like the custom PS sections, like the same way the same command issues for specific things, and so on. So this is another way. Another point of view, which emphasizes more the timeline between those ransomware. It is possible, we highlighted in red the things that are more strong, the commonalities, sorry, that are more strong in between those variants. And it is possible to see that they shared a lot of things. There are a lot of elements shared between those families. If we take a look also at the timeline that I reported on top of each block, on top of each ransomware families, also the timeline is congruent with the operation. What does it mean? It means that, for example, we consider that we don't have much overlaps between Western Logger and the AIDS. Yes, there are a lot of similarities, but we don't have a huge overlap in terms of code. And why? Because they had the time to rewrite most part of their code in order to alter the signature. And it is consistent because they started, probably they started to write HADES in the summer 2020 when they finished to operate the Western Logger. And in fact, it took 4 or 5 months to develop HADES. In fact, the first sample of HADES dates back on November 2020. And this is consistent with the effort, with the time spent in order to introduce those modifications, to introduce those new things. So if you consider, for example, the time that lasts from HADES to Phoenix Logger, HADES was operated until March 2021, and Phoenix Logger was operated in March 2021. In fact, Phoenix Logger appeared when HADES ended their operation. They have no time to spend to write a new ransomware, to rewrite new things. In fact, they took an HADES sample and put a lot of junk code after the signature, change minor things inside, and they operated this new strain. So also the timeline is consistent. Some important findings that I'm going to summarize in this slide. First of all the ransomware families were developed by the same factory. It's evident because it's evident the reuse of code and knowledge between the different variants. And considering that another important findings of our assessment is that all those operations have a unique direction. Why? Because each operation is tightly connected to another. And considering that some people can take from the same repository, for example, no, we can have also different ransomware families which overlaps because someone took from the same repository. But the interesting things here in all those operations is that it's not just an overlap of code or similarities in TTPs. It's the way they operate their ransomware. In fact, it's interesting to note that from the ransomware, there are few hours from the ransomware build, from the development, from the building of the sample until its deployment. There are only few hours. And this is a distinct element, this is an important element that led us to assess with a high level of confidence that all the phases of their attack chain are tightly connected and orchestrated. A few weeks ago, another ransomware hit the headlines called the Macabre ransomware. And some researchers claim that it's related to EvilCorp in some way because it is derived from the same code base of HADES and Western Logger. We had the opportunity to assess it, and I want to show you in preview our assessment on it. Considering that it's a sample, here they implemented a lot of techniques for evading sandbox or for anti-analysis, and it's quite difficult to assess and all those functions. For this reason, we decided to spend some time in trying to reverse engineering it, and we were only able to assess a few functions. Mainly, we assessed the file and directory enumeration routine and a little portion of the beginning of the encryption function. So it contains a lot of no opcode-like instruction, like we seen for HADES, from HADES onwards. A lot of jumps in order to mislead as an anti-analysis techniques, and a lot of indirect calls through all the binary. This is also another anti-analysis techniques. So first of all, yes, the first things that they introduced here is that in Macav is used a technique to dynamically fetch the address for API. They don't put statically API names in the import address table, but they use they fetch dynamically the address of the function as a way to, yes, as an anti-analysis technique, of course. Another techniques that they implemented as anti-analysis is to the indirect calls. They don't use the real reference for each API that they invoke in the code. For example, in this screenshot on the right side of the slide, we have an example of how Macav calls the RTL allocate heap, which is a function responsible for the dynamical allocation of the heap in memory. And they calculate the destination address dynamically, put it in the AX, and moving the value from AIX to the top of the stacks, and then called a ret instruction in order to jump to this address. This technique is effective in slowing the analysis, and is effective because it's require a lot of time in order to reconstruct all the functions. So this is a detail taken from the analysis of the drive enumeration function. We compared this function between heads on the left and of course in Macav on the right side, and is partially identical. What does it mean? It means that the implementation is not one identical, that doesn't overlap too much, but the semantic, the logic is pretty the same. This is a clear, it's clear here, sorry, another attempt to change, to alter the signature and to insert anti-analysis techniques. The semantic is the same. They use the same API in the same order, but they use in a different way. The implementation changes because they reconstruct dynamically the right reference for the API instead of calling it directly. So another example taken from this is taken from the beginning, from a portion of the file, of the encryption function, and is practically identical from the logical point of view. The implementation changes because they adopted this technique of indirect calls inside Macav in order to mislead the analysis, but the logic is the same. For each API that we can see, for example, on the left side, get let attribute, for example, we have the same, but the implementation just changed because they get the right reference with the indirect. It is called an indirect call. They can extract the right reference to the API dynamically. So Crypto1 is another special component in the EvilCorp ecosystem. It's a kind of pager. It's also known as Halloween pager, and it's a special pager which provides a lot of distinct features, like, for example, sandbox evasion feature or anti-emulation or code of flow obfuscation. And it's mainly used, historically mainly used by EvilCorp, but it's also used by different other, was reported to be used by also other threat actors. Was first reported by Positive Technologies in a report, and it's a kind of service that is advertised on some hacker forums. So Crypto1 is the packer that EvilCorp choose for pegging to make their ransomware more evasive in some way. During our investigation, we were able to spot a different version, different flavor of this crypto, and which have never been reported previously in our report. This permits us, in our investigation, to put in the right place in a timeline all the ransomware, all the ransomware operation. So how we reconstruct the timing of this operation with relying on crypto one. But there is a problem. We all know that the compilation timestamps could be tampered in some way. And we conducted a kind of analysis on the validity of that compilation timestamps as a first step, because we want to first of all assess if the compilation timestamp of the sample was altered or not. This is crucial, because if we found in the end that the compilation timestamp is solid and was not altered in some way, this permits us to put all the things in the right place in the timeline and also in a reliable way. So this is the summary of our threats to validity about compilation timestamps, for example. There are four main observations that I'm going to share with you. First of all, sequential consistency. The validity is weak. What does it mean? It means that if we can take into account the different ransomware operation from Western Logger to the most recent payload bin, we see that each of those artifacts have its own compilation timestamp. And if we put all those compilation timestamps in a timeline, we see that there is a kind of sequential consistency. This means that, for example, every AIDS samples that you can take in the wild contains a compilation timestamp which is consequent to Western Logger, for example, to any Western Logger sample, and so on. This is a weak assumption. This is a weak assumption, but it's important. It's a first level of assessment on the validity of compilation timestamp. The second observation is that there is a kind of consistency with the timing of the operation. What does it mean? It means that even if the timestamps could be tampered, it falls, each sample falls in the timing of the operation. What does it mean? It means that we know the exact, for example, timing, the time range of the operation of AIDS. We all know the exact time of the operation of Western Logger and so on. If we take, for example, any Western Logger sample or any AIDS sample, and we check then the compilation timestamps, those timestamps falls always in the exact timing of the operation. Each timestamp of AIDS, of any AIDS sample, for example, fall in the exact time range of AIDS operation. This is a more strong assumption because even if a threat actor could modify the compilation timestamps, it remains consistent in time, because it remains consistent within the timing of the operation. We also did other observations like statistical and chronological consistency about those timestamps. And also, and yes, we assessed that there is a kind of statistical consistency. For example, we checked the submission date on VT of each samples that we analyze. In any case, the submission date is next and subsequent to the compilation timestamp. This is another element of validity, because even if a threat actor can modify the compilation timestamps, it remains consistent because also the submission date is consistent with the compilation timestamps. The last and but not least observation that we did during our assessment, and it's the more strong in our opinion, is the consistency with digital signature date. Each artifact present also most of the artifacts were also signed with a legit issued certificate, and we have for each sample we have also the certificate we have also the signing date of each certificate. Querying a certification authority, we were able easily to find when a specific certificate was issued. For example, we have the timestamp of the issue date of each certificate. Comparing the issue date of the certificate used to sign digitally those artifacts is consistent because it's next to the compilation timestamps, is next of a few hours or few days. Combining all those observations, we can assess that is almost certain that the compilation timestamp was not altered in some way. So at this point, once we confirmed that the compilation timestamp is good and was not altered, we collected at scale all the crypto1, relying on some crypto1 signature. We collected at scale all the threats, all the malware that in some way were pegged by this crypto. And we put and cluster all the threats that we were able to collect in this table. And there are a lot of interesting consideration, because, for example, the first instance of crypto1 dates back in the late 2019, for example, and was used to crypt, to pack networker and databot. The first usage by Western Locker dates back by the beginning of 2020. In fact, in some crypto1, collecting some crypto1 samples, we found some Western Locker inside, which are consistent with the timing of the operation of Western Locker, because it's supposed to be to start their operation in the beginning of 2020. And also, yes, I highlighted in orange in this slide the cluster, the flavor of crypto1 used by EvilCorp. And for example, we see also different signature used by Western Locker in the second row of this table, and in the fourth row of this table we have Western Locker, and also later in the last row of this table with the signature 1111 we found Hades, Phoenix, and Payload B. All those ransomware families reported in the last row of this table were packed with the same crypto1 version, with the same stub. This is an important element because crypto1 is a packer as a service, and it's advised like it is advised actually with a lot of providing also unique stub for each customer. The crypto1 signature, like in this case the first column of this table, it's also a signature that can be used to statically detect those threats. But it's also a marker for us that permitted us to cluster all their operation. They use the same stub from Hades onward until Payload B, not in Macav. In Macav, seems that they use it, for example, VM Protect. Why? Because they remove it. If you take a look statically at the Macav ransomware, for example, they removed a lot of VM Protect markers, like the VM Protect sections, for example, in the portable executable and other markers in order to mislead the analysis. But the style of code and the style of indirect calls, and the style of code led us to think that they used VM Protect this time, and not Crypto1 anymore. So Crypto1 was it's a crucial element in all the investigation, because permitted us to cluster and put in time all the activities. And yes, we presented a lot of similarities, a lot of strong overlaps in terms of code, in terms of configuration, in terms of TTPs. But we have combining, putting all those samples, relying on Crypto1 signatures, we were able to put those events in time, in a timeline. And if we put all these elements in the timeline, there is a kind of congruency between congruency and consistency between all those operations. It's interesting because, for example, from a certain point in time, about the late 2020, they start using with you can see it with a blue line. They start using the same stub, the same Crypto1 version to hide all their ransomware from AIDS onward. Before they used a different version. In fact, we can see, for example, the orange bar. In the orange bar, which dates back, started in the beginning, in March 2020. At that specific moment in time, they're introducing WastedLocker, no longer use Bitpaymer, and start then using SockGolish. And if you can take a look from the March 2020, the orange bar, okay, they start using Crypto1 for hide, to change the signature of WastedLocker, okay, and they also used three different signatures, three different stubs for WastedLocker. But from a certain point in time, around the September 2020, they used the same stub for a kind of, they established a kind of what it seems a kind of a special relationship with Crypto1, or with the threat actor supposed to be behind Crypto1. And this is very interesting because Crypto1 is advertised as a kind of as a service thing, is a baker as a service. And for this reason is not supposed to be in exclusive use by a single threat actor. But observing this timeline seems that from a certain point in time, it is in exclusive use by EvilCorp. And this is interesting because there are we're not find any other threats in the wild pegged with this pager from a certain point in time. And this led us to think that from a specific moment in time, even considering that this is a kind of as a service thing, they start to establish a kind of special relationship with the threat actor behind the Crypto1 for a number of reasons. First of all, because they tend, and this is a distinctive element in the EvilCorp ecosystem, in the EvilCorp TTP. They tend to maintain the control over all their operation, and in fact also in the resource development phase, because the pager is fall in the development phase, no? The pager falls in the resource development phase of the attack chain. Even if the pager, they tend to maintain a strict control over the pager, even if the pager was advertised as a service. But they want to maintain and to keep control over it. Why? First of all, because if this pager, for example, was used also by other threat actors in the wild, they had less chances to lower the detection because the signature was widespread in the wild, and for this reason they had no chance to lower the detection. So also from the packer point of view, they tend to maintain a strict control over each phases. And this strict control we can observe from this slide in a blue bar, because from a certain point in time, they use Crypto1 in exclusive use. So what are the conclusions? First of all, that it's difficult to cluster all the EvilCorp, to track this threat actor for a number of reasons. Because this threat actor put much effort into continuously change its skin, of course, and have a great capability in resource development. In fact, they tend to maintain a strict control over also in the development, in the resource development phase. And this threat actor changed a lot of times TTPs and also tools. For example, from Bitpaymer to WastedLocker, they switched from Dridex to SockGolish, for example, or they adopted new they switched from Empire to Cobalt Strike as a post-exploitation tools. Or for example, in Macav, they used other advanced and sophisticated anti-analysis techniques, and they changed continuously their TTP. This is the main reason why it's so difficult today to track this threat actor. We assessed that that is almost certain that all those ransomware variants from Western Logger, from Bitpaymer to the latest iteration Macav, were all developed by the same factory. And because there is a significant code reuse between all those ransomware variants. But our temporal analysis permits us also to do another level of assessment that, okay, it's they have the same code base, they have the same factory, the same repository, but all those operations are strictly also are tightly connected. Sorry, because from the resource development until the packer, when the sample is packed, until when it was then deployed, there are few hours, and all those operations from the resource development to the ransomware deployment are strictly connected and synchronized by a single direction. This is an important, the most important findings in our investigation. So from the ransomware perspective, they implemented specific techniques to evade EDR and to stay under the radar, to lower the detection. The partial rewrite in native API that we see from Hades on Word, for example, the custom implementation of static polymorphisms, which alter the static signature and is quite effective in lowering the overall detection that we see that they introduced starting from Hades on Word. And also the ability to maintain a high level of OPSEC. It's a distinct element in all their operation. To evade detection, but also to stay under the radar. And last but not least, the ability to change their skin continuously. The skin, I mean, the ransomware signature, the way the ransomware is deployed, their TTP, for example, in a short period of time. For example, the adoption of SOC-Golish, when they switched since the beginning of 2020, they switched from Dridex to SOC-Golish, or the usage of Kodiak instead of using PowerShell PowerSploit framework, for example. This is another distinct element in their TTP. In fact, they tend to use less common and less detected tool inside their operation. So victimology remains still an open question in the community due to lack of shared intelligence, and for the main reason of the implication of this sensitive matter. The group main motivation remains still an open question for the community, because considering the documented ties with the Russian FSB and the way they operate those ransomware, because they are operated in low volume, and also the choice of the victims led us to think that it's likely that they use those ransomware operation like a diversion mechanism, like to mask other espionage activities. Thank you to all attendees.